Hello, class. This is the Chapter 8 lecture for our class. And so now we're getting a little bit more exciting because we can really start to do more with our programs now that we cover strings, which represent character strings, and vectors, which are very similar to arrays in some aspects, but they're more useful and they are more powerful and more maintenance free than just plain arrays. And you'll see what I'm talking about as we go along, so let's go ahead and dive in. Right. So first we're going to be covering character arrays, which is the old C string type. Then we'll go over the string class for C++, which is, more useful and more powerful, as well as vectors, which can sort of be thought of as improved arrays in some respects, and we'll see what I'm talking about. So first we'll go ahead and go over the old C-style strings. And this is basically a character array. So what a C string is an array of characters. And we'll go ahead and look at one here real quick. Let me get rid of some of this garbage. Sorry, I have a program here. All right, so we'll go ahead and take a look. So like I said, strings are character arrays. The C-style strings are anyways. They don't require any special libraries headers. So we go ahead and declare an array, right? And I can initialize this array. So take a look here. What I've done is I have an array of 1, 2, 5, 6, 7, 8, 9, 10, 11, 12 characters, right? And go ahead and compile and link. Run it. All right, hello world. Yeah. So you see I have an array. I don't have to specify the size because I initialize it as part of declaration. 12 characters, and I go ahead and display the array here. So the array, C string can directly interact with the standard output. Now, I said I had 12 characters in it. It's actually 13. It's 13 because there is a special null termination character that's appended to the end of every C string. Okay, so let's see here. Oh. All right. Oh, I don't have a semicolon there. That is a problem. Oh, yeah. Okay, so I must have been inadvertently deleted the closing brackets, my main function, and now should be good to go. All right. Yep. So C13. So I have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12 characters in this array, and then I have my special null termination character. So that brings me to 13. It's there so that the system knows stop when displaying and so forth. Okay, that's a bounds check addition. So yeah, also we could do this. You see they explicitly declared the size, and they did this because they didn't initialize it upon declaration. So we could do something like this. This is exactly equivalent to what I just did. File and link and run the same way. Oh, wait. Invalid array. Oh, yeah. Sorry. Just all right. Yeah. So I was treating it as a regular string. So there we go. This should go. So you see 12 and the implicit termination character, so 13. So this is a problem. It'll probably compile. Let's see here. Actually, it's not. My compiler caught this. Initializer string is too long. Okay, so just know that there's the null termination character. And you see, if you look at this, if you don't know about the null termination character, say, wait a minute, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there should be no problem. Well, forget the null termination character. And with C strings, you have the null termination character always. So yes, as I said, if you declare an array of 10 characters, it's really going to be 9 because you've got that default null termination character. Okay? And correct. So you don't need the size variable. And you know, when we say size variable, you could have the variable passed to a function so that you know when to stop evaluating the array. In strings and C strings, all you have to do is look for the null termination character. If you step through this array, you know, for I equals 0, I is less, or well, you know, array bracket I, for example, is not equal to null character, which is this \0. That way, you know, when you say I++, you can know exactly where this string stops. Once I evaluates to the \0 character, you stop. You stop evaluating the array because your C string has terminated. Yeah, and we saw basically this is the same thing. Character, array name, array size, +1, you know what the contents are. Okay, and again, the +1 is because that null termination character. Okay, and yes, as we saw, I defined it actually. I initialized it 2 ways rather. A definition. I did it 1 with the size, and number 2 without the size. I did it without the size. Notice that that won't leave me room for addition. If I want to add on to that string, I have to create a kind of a new string. However, since they left themselves some buffer room here, so you see they have 20 characters, and this is a 1, 2, 3, 5, 6, 7, 8, 9 character array +1 for null termination, so size is 10. So they will be able to concatenate up to 10 characters onto this. You know, concatenation is basically adding. Okay. And this is what we saw. This is what I did. However, you cannot initialize a C string this way. And really the reason is there's no null termination character at the end. You actually can do this. If I'm not mistaken, my compiler will not gripe at me. But you will run into problems when you look for that null termination character at the end. Yeah. I went ahead and did it. However, you will run into some problems. Yeah, exactly. You don't have a null termination character at the end. Yes, and this is a good point, when you are manipulating variable, when you're changing the characters in a C string, stop at that null termination character. Don't override it. Don't override it, or you'll end up in an infinite loop, most likely. So to look at that null termination character after you change it, it won't exist, and you'll keep searching through memory. Okay, eventually you overrun the bounds allocated to the process, and the operating system will terminate your C++ program. So yes, this code, good point, this code depends on finding the null character, and this is exactly what I'm saying. So you keep stepping through this array, you know, either with the for or with the while. You're looking for a null termination so that you know when to stop. Okay. So you need that null termination character at the end. You can also use a size variable in addition, just in case this \0 gets erased. But if you're writing \0, you have other problems as well. Okay, so this is kind of a fallback. So this looks for the null termination character and says, hey, you know, let's also make sure we don't overstep the size of our array in case this \0 has been obliterated. Okay. Great. As we saw, this doesn't work. This isn't an initialization. This is an assignment. And yes, the assignment operator does not work with C strings. Remember, I did this just a minute ago, and as soon as I did it, I realized what happened. It's not a string. It's a C string. It's a C-style string. Okay, you can't directly assign to C strings. There's a special function. And we'll see that in a few slides. Here it is, actually, one slide. strcpy, string copy. So what I can do, this will actually require the C string header. I believe it's C string. So I can copy a literal, a string literal. I believe it's destination and then source. Actually, let me make this a little larger here. Okay, and this should work. I coded this hastily, but it should work. Yes. So strcpy, I can copy a string literal into my string, or I should be able to say and copy from, let's see here. Oh, you know what? Let's keep this. All right, so now I've copied hello world into C. What I want to do is copy C into C1 and then output C1 so that we can prove that the string copy function will work from C string to C string. So I'll copy to C1, the contents of C, and let's give it. Hey, all right, good deal. And it does copy the null character as well. It copies that null termination character. Okay? Even if you input a string literal, it will copy hello, and then it will also copy \0, the null termination character. That's all one character, by the way. It's a special character. So correct. String copy doesn't check the length of your first C string. Okay, so your destination could be overrun. And this is what it's saying here. You can write characters beyond the declared size of the array. So you can write into junk in memory behind your string. That could be very problematic to have strange string behavior in your program and not know why, because the compiler probably will not gripe at you. Okay, strncpy. So this is useful, however, look at the problem here. We basically, you can think of it as string copy up to n characters. Okay, and that's what this third argument is. This is the maximum number of characters to copy. It's saying, hey, don't copy from the second argument, don't copy any more than this number of characters. So you see strncpy would copy the first 9 characters of a string variable into another string, and then it would append the \0 null termination character to it. So that's strncpy, but you see the problem I'm talking about. You have to know how many characters you want to copy. Now, as far as how many you would want to copy, here is a helpful little tip. All right, so I've got my 13 character array. Well, you know, do we really have to know the size of the array in advance? Well, no, because okay, objects have the size of operator in C++, which will obviously give you the size of the object in bytes. Now, if you're working with integers here, actually, you know what? We'll go ahead and start with. I'll go ahead and output the size of this array. Gotta love the suspense as you compile. Is it going to compile? Is it going to errors? Nope, no errors. All right, so I'll go ahead and run this. Okay, so the array is 13 bytes. We knew that, right? 12 plus 1 is 13. We can all do math. We should be able to anyways as computer people. But aha, problem. Okay, so I declared an integer array of length 13, but row, oh man, our size of stopped working, didn't it? No. That's why. Because each integer is 4 bytes. Okay, so 452 divided by 4 is 13. Yep, 4 bytes. The whole array is 52 bytes. So then we can say this. So we don't necessarily, sometimes it's a good idea, but we don't necessarily have to use that, explicit. We don't have to know in advance our size operator. Or our size, constant anyways, as the book, would have you believe. So, there we go. So that's how we know how many units, how many elements are in our collection, in our array there. Okay, next slide. All right, so yeah, you can't directly compare two C strings. You can't use equals equals. That is simply not going to work, okay, because it's going to kind of treat them as points. So what we can do, we can use a string comparison. Now, we'll go ahead and make a few characters. All right, so what I've done here, I've created a character string C, that's hello. There's a matching character string C2. Now there's a differing character string C1. Let's go ahead and use our string comparison. Okay, these we know are different, right? C and C1 are different. Okay, C1 and C2 should be equal. At least these strings, these string contents are equal, right? I should note also, this C string header is necessary to use strcmp, to use a string comparison, the STL string comparison function. Yep. So when two C strings are the same, you'll always get 0. If they're different, you will get a non-zero number. Okay. There you go. So you see what they've done here. If strings are not the same. So remember, when you look at this may blow your mind, so think about this. If always returns true if the result is non-zero. So if string comparison is not 0, then this goes true. So that would mean that the strings are not the same. So that's what you're seeing here. This is kind of as a double, almost a double negative, if you will. It's a little tricky there. So just look at it that way. Right? In fact, let's switch these around. See? So it depends. Could be positive, could be negative. As long as you look for not 0. 0 is they are equal. Anything other than 0 means they are not equal. So yeah, compared to the ASCII codes of the elements, and of course if they're all the same, it returns 0. It will return negative. The first value, if the first C string is less than the second, or return positive. The reverse is true. See, note in this case it's positive because there is, ASCII medical is greater than hello, and vice versa. Lowercase t, I guess I should say, is greater than, ASCII-wise, greater than the uppercase H. So we have a length, we have a string length. So here we're getting even more useful. We can kind of extend our size of operator. We can just say we don't even need all that junk. We have a string length here. Now the string length returns the number of characters in a string. So let's do this. Sorry, just one sec. Excuse me. Okay, sorry about that. So we are looking for a string length on our character string C. Okay, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, remember that our array length is actually 13. Okay, so this indeed does return the number of characters in a string minus that null termination character. Okay, we have our string concatenation function, strcat, and it'll concatenate a string literal or well, here, this str. So we'll go ahead and concatenate C with make enough room for it. We'll say, gosh, hello world, nice to meet you. So this should say hello world, nice to meet you. That should be then, actually here. Yeah, that should return the string hello world, nice to meet you. Yes. Now what we can also do, just to show you this isn't a literal, this isn't a C string and a literal mix only. As long as we have enough characters reserved in our C, in our string C, we should be able to do this. And it should say the result should be the same. Hello world, nice to meet you. sorry, just a sec. I expected. Oh, must have obliterated that semicolon without realizing it. Yep, hello world, nice to meet you. Good. strncat. So remember, the n is the number of characters. So concatenation up to a certain number of characters. So that's a limit on the concatenation. Right? Strings as arguments of parameters. So C strings are arrays. They're arrays of characters. They are used just like arrays. Okay. The only difference is that they have the null termination character at the end. So they can be a little bit different in how we evaluate them inside functions, but otherwise pretty much the same. Okay. So yeah, if a function changes the characters inside the C string, you should adjust the size. If you're using the declared size, you should adjust it as necessary. And if it doesn't change any values inside that string, then of course, there's no need for it. You just look for the null termination character. Since you're not changing or moving that, it doesn't matter. You don't have to keep track of any size in any circumstance. Okay, so again, we saw this several times. I'm not going to show you again. We saw that see how it works with C strings. You just see out the name of the C string. Okay. Now you can, with a caveat, you can fill a C string with CN. Okay. So let's see. We declared two arrays here, and we prompt for input. Now, notice what it does here. What it does is it stops at the first occurrence of what we call white space, which is, a space, a tab, anything that's, not a character. Stops and will fill this A with the word do because it stops at the white space and says, oh, I'm done. Then, since we're looking for a second argument, it will stop at the end of B since there's more white spaces. Oh, I'm done. And I'm going to put the value of B, the word B, into the character string B. So that's why we have do B. Okay, so CN stops at the first occurrence of white space. We'll see an example of this. It's always easier that way. All right, so I'll enter hello there, world. You entered hello, right? Remember, it stops at the first occurrence of white space. So now the string only contains the word hello. Yeah, if we want to read an entire line, this is a little bit different. Okay, CN does have the get line function. Okay, it's in the standard template library. We don't need to explicitly code it. It does everything for us. Okay, has two arguments. Okay, first is the string that you're reading into, and the second is the maximum size of the string. So now we'll change this a little bit. CN get line. Okay, so we're reading into C, and we're reading, oh gosh, since our character array is 100, we'll read 99 characters. Okay. Load their world. Hey, that worked. All right, good. So CN getLine will not ignore and terminate at white space. Okay, and it does also add the null termination character at the end. Okay, if we were to look at this, we'd say, this is 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This should be a 19 character C string, or character array, C string. All right, so yeah, this is the same thing we just did. Again, it will include the white space into the string. Won't stop at it and terminate there. Okay. Okay, getLine stops when reading the number of characters less 1 specified the second argument that is placed in the C string. Actually, so you know what? Now that I guess I forgot about that. I could actually have included, I could have said 100 here because CN will actually stop reading at 99 characters and then append \0, the termination character on the end of that. I forgot. I didn't look at the, the STL documentation. That's true. So I could say 100 here, and it would read 99 characters. As I had 99, it would read a max of 98, and then add the null termination character. So we can actually include the full length of our array in here as the maximum number of characters argument. Yeah, so input and output, they are streams. They work the same way as other streams. That's all this is saying. So this is an input stream. Now we're saying is, get everything in the C string, this string C string, with a variable name C string up to 79 characters, and then we'll add 1 for our null termination character. And the same for out. C out is an output stream. That's all this is saying. Okay. So, this is in the context of files. So, our input string could be a file. Okay, so we could be reading in from our file or writing out to our file. That's all this is saying. They are input streams and output streams. So CN is a type of input stream. Cout is a type of output stream, as are input and output files, streams. We've seen this. Okay, we call CN dot getLine. GetLine is a member function of CN. Okay, then we put our C string and our number of characters plus 1 that we want to read. Again, it's just an input stream. We can replace CN by anything. All input streams have this getLine member function, member method. All right, so now we're getting a little bit more useful. So, we can read in characters, but what if we need to do stuff with them? What if we want to make sure, let's say somebody enters 1234A. We can't convert that to a number. It's going to be a problem, right? All right, well, what we can do, we can read it in as a string. We can strip it of non-numerical characters. Then we can convert it to, let's say, an integer. Okay? And, they have the example here of reading money. Okay, sure, you got a $sign. Okay? Reading percentages. Sure, if you want to convert a percentage to a double or to an integer, if it's a whole, integer percentage, you have to strip the $sign. Okay? So we have 2 useful functions. Actually, we have a bunch. We've got A to I, and you can think of this as maybe, if you want a mnemonic, well, not really a mnemonic, if you just want a good, handy way of thinking about it, you can say ASCII, because, strings are made of ASCII characters, really, basically, anyways. ASCII to integer. So let's see an example of converting a string to an integer. So let's say enter an integer. So we are going to be looking for a string. Here, you know what, we'll do this. This is the standard library. Yes. All right, so now I'm going to go ahead and enter, fictitious integer there. All right, good. This worked. So look at what we did. I prompted for an integer. We read in a string instead of an integer. I can't multiply a string times 2. That doesn't make any sense. Okay, compiler will gripe at me. It will not compile. So what I can do is I can say, okay, I'll convert this string to an integer, this string that I call C, this character string. And then once that is done, I will multiply that by 2. Okay, and then I'll push the value into I. So really I didn't even have to declare this I, just say that. This will work, this will compile, and it's done. So you see what we're doing. We're reading in a character string, converting it to an integer, and then, oh, well, you know what? I said it will compile. I kind of, there's a little silly freshman mistake there that I made. So yeah, we can convert strings to integers this way, and this is very useful, again, when you want to strip either incorrect or formatting characters in. Okay, so know that we can do this. Now, a couple of other handy things that we can do. I'll say enter a double, enter a float. Here, you know what? Enter a decimal value. That's probably going to be most intuitive to people. All right, we'll read in up to 100 characters, or up to 99, actually. Okay, and A to F. All right, A to F, you can think of it as ASCII to float. Okay, it will give you back a floating value. So I'll enter a decimal value, convert it to float, multiply by 2, and read it back to the user. I think I already compiled it, but just to make sure. Yeah. Enter decimal value, 9.9. I would expect back 19.8. If not, I'll look at it, see what the problem is. Okay, yeah, twice the amount you entered is 19.8. Now something else we can do. We also have A2L, ASCII to long. That's going to give me a long value. So I can enter, just a huge value, greater than normally, an int would allow for. I think an integer is, we said 4 bytes on my system. So see here, can we do some math? 2 to the 32nd. So really anything above 4,294,967,296. You'll know that number by heart if you're a hardcore network person. That's the limit on the number of IP addresses, right? 32-bit IP addresses. So what I'll do, I'll input any number greater than, about 2.2 billion. 2.2 billion, 800,000 million billion. Wait, something's happened here. Let me try this one more time here. Curious. Yeah, we're getting some overflow here. Let me look at something just a sec. Okay. What I'll do. Long max, I believe. I have to include the limits better. I just want to look and see what the max value is here. I suspect that I'm overrunning it. I just want to make sure that I'm not leading you in the wrong direction here instead. Yep, longest 4 bytes. Okay, so really that's the problem right there. So what I could do, I could probably use an unsigned long. Instead, you see the problem. My long on my system is the same width as an integer. So really the solution would be to use an unsigned long, but that's fine. Really, when you see this negative and you know you got positive numbers, just be aware that that's kind of a red flag, if you will. There's integer overflow. And really what that means is that your integer is so long that it wraps all the way over to the left-hand side, and it will flip your sign bit on your integer. So you'll get some negative values where you know you should have positive. And that's what's happened here. Anyways, if you need to convert to a long, you can use A2L. And yeah, good point. So if you go to convert an integer and it's not valid, it's going to return 0. So let's put some formatting crap in here. We'll put, I don't know, delete this here. Some junk in. We'll say 1, 2, 3, 4. Oh no, yeah. Well, that's what happened. It can't deal with the pound, the asterisk, with hash and the asterisk. So it returns 0 instead of a valid value. Doesn't give you a runtime error, but it will return 0 instead. Just know that. So yeah, again, as I said, you can strip formatting characters out, and you can strip incorrect input out this way. If you just want to read in numbers and you can go through the character array number by number, and if a number is, or rather if a character is non-ASCII, you can strip it out of there. Okay, so that's kind of a way of doing, input validation. Or you can display a message back to the user and say, hey, only valid numerical input. Okay, yes, A2L. A2L returns long. Again, beware, as we saw in my compiler, long is 4 bytes, as is integer. You can use unsigned long for such cases, but you only function here A2L. You do have a string, str2L, which, strings, regular strings, shortly. Yes, as we saw, A2F will convert them to a double floating value. Again, you got to strip those formatting characters out if you think that the user may give you input, which happens all the time, or if you may get invalid input from some data source, be it a database or a file or whatever you're working with, you strip the non-numerical characters out. Well, obviously other than the dot there, as well as any white space. Okay, ASCII to integer, ASCII to long, ASCII to float. Now, you saw what I had to do. I had to come in here and put in standard library. They're part of the C standard library. They're defined there. So in order to use these functions, the compiler will need to get their definitions from the C standard library. So you have to use pound include C standard lib, CST lib. And we have just an example of reading and kind of sanitizing the input. And we're not going to go over these. I'll leave this to you because I'm droning on and on. We've already been here 25 minutes, so we're not going to try to stay here 2 hours. So check out display 821, 822, and as well as 83 because that contains an auxiliary function. And ask any questions if you have any questions. However, it should be straight by now. Okay. We went over benefits of reading numeric data as characters and sanitize our input. Strip adding characters. We can strip any data that shouldn't be there. Okay, write code to do input and output with C strings. That's very vague. That's up to you. We have exercises at the end of the chapter to work. We have coding exercises, projects. So we will hone these skills. Yes, we saw A2I, A2L, and A2F. We saw them used. You can always go back in the recording and pause. You want to kind of parrot some code. The character then C string, as we saw, it is the null terminator character. So now moving on a little bit more in utility is the string class. Okay, so now that we looked at C strings, you don't want to use those. You generally don't want to use those. Stay away from them. They're very error prone. You have to keep tabs on the size. You have to look for the null terminator character. All kinds of things. We want to keep it simple, stupid, right? We want to keep it as simple as possible. We write millions of lines of codes, and there are bugs we'll never. So we want to cut down, make things easier and more bulletproof for ourselves. Okay. So we have our string class. It's a good bit better than the C string class. Okay. So string is kind of a, it's a basic data type. It almost behaves as a primitive in that it's not made of smaller, there are no component elements, string. Okay, so that kind of gets a lot of this junk, a lot of this overhead and burden off of us as programmers. We don't deal with C strings, but instead deal with string class. Okay, this is defined in the string library. You can, yes, you can use the assignment operator directly with strings. Don't get C strings and strings confused. Go back to this PowerPoint, go back to the section on C strings, go back to the section on strings as necessary. If you ever think you may be confusing the two, or if you don't know why something's doing something with strings, go back to this PowerPoint and go through. Okay? And you can see we just defined a string. We just declared a string. We can go ahead and initialize it, declare it. We will need to change this. It will say string. So we can say string s equals hello world. Or we can say string s1 equals hello world, right? Either one's going to do the same thing. See out s, get a space between them, s1. Right. And so that's how we use strings, at least the most basic form anyways, just declaring, initializing, and outputting the console. Yep. And you can concatenate strings. Simple plus. So check this out. Do it real quick. Easy enough to understand, so spend too much time on it. Really should be asked to. So we should see another line with also hello world on it. All right, good. And notice it doesn't have the space there because that space is not in C3. It's simply C1 plus C2, which don't contain any spaces here. Okay, and better yet, the compiler will allocate more space for you. If S3 isn't big enough, it will make S3 bigger here in this example. So that's great. Again, we're relieving some burden off of ourselves a little bit, getting a little more robustness and bulletproof behavior here. All right, another way we can do it, we can just use parentheses with the string literal, okay? Or with another string we're copying from. Now, you don't want to mix strings and C strings. There are conversion facilities, however, this isn't going to cut it. Okay, if you try to mix string literal and C strings, it's not going to work. Okay, you have to, again, there's a conversion facility. You can define your own operator. You don't really want to do that unless you know that's a little further down. Okay, so just know that. You want to mix two there in the same string. As we saw, we can see out strings. We can see in string. Okay. Okay, notice what it does. It stops at white space just like C strings. And that's what this is telling you here. Skips white space, stops on encountering more white space. So CN is limited, again, for strings as well. Now, there is a string get line. This is not the C string. This is not the CN get line. Okay? This is a string class get line, and you notice it takes two operators. It takes, or two operands rather, takes the input string, which in our case will CN, since we're reading standard input, the keyboard, and take string writing into. So now we can change this CN a little bit here. We can say get line. I'll read from CN and I'll read into S. Notice I don't have to declare a size of S or anything. That's great. So I'll go ahead and compile, make sure this compiles. Okay, hello there. Now we should theoretically print out hello instead of S. So we just saw it exactly. Back. By the way, I don't like the way they do these. They really should have a backslash n right here or an endl here. So there's a separate. Okay, so extraction operator, CN, can't be used to blank character. Yeah, to read one character at a time, we'll use cn.get, and it reads in characters. Okay, take a look at 851 and 852. Cover these concepts enough. I'm not going to step through the examples. Now, there's an overloaded. Okay, so see, the get line, the string get line is an overloaded function, meaning that it has more than one definition. One definition, the 2 arguments. Yet another one is the 3. So what this will do, this should look at input and stop upon encountering this, for example, this question mark character. So if we want to extract, oh gosh, I don't know, say we want to extract, here, let's say we have some line in a text file that, our separator character is the colon, and let's say we want to get the first value out of that. We'll fake it. We'll use standard input here. But, you can make sure this is reading from a file. So what I'm doing, I'm reading in from the keyboard until I encounter the colon. Then I'm parroting back what? So say it has some values on a line, value 1, 2, value together. I would hope that this returns value 1. Hey, you entered value 1. Yes. So termination character right here. And when I say I hope and perhaps and whatnot, trust me, I do know this stuff. Just look. And, hey, if something goes wrong, I can't act like I'm God here. Something wrong. It looks silly, not about silly mistakes. So don't doubt me. And again, I'm not. Okay, so get line returns a reference to its first argument. All right, so this returns a reference to CN. Now, For example, what we have here, we find two strings. Okay, we're getting string 1 from standard input, and this example is actually and then we're going to read in from C2. Okay. Now the difference here is that S1 will not stop at white space. Remember, it will a whole darn line, a true whole darn line, and then S2 will stop at the first white space character. Matter of fact, let's go ahead and it's a little confusing. Yep. So, as I said, we read in a whole darn line. That's what S1 is. Okay. Remember, get line, we're reading from CN, standard input, to S1. Then we're basically doing a CN on S2 again. So that's why we stop at first white space character. Again, it's a lot. Chaining these together like this is a little silly. I didn't need to do that, but you see the output. All right. And this is basically saying, yes, it returns a reference to the input stream. GetLine does. So getLine with the input stream string that you're reading into in the delimiter character will return a reference to the input stream, as well as the 2 argument version. Okay, mix CN and getLine. So again, CN stops at white space. It doesn't include it, and it stops at it. CN will, and it does leave. Well, I actually didn't say this before. It does leave the new line character in the input stream. The example here we have an integer, we have a string, feed in integer, and we get line. So this leaves the \n, which begins get line's reading. So watch this. All right, so we're going to read in a number, row. So see what happened there. This is what it's telling you. CN will leave the \n in the stream. So, when I read this integer, there's a \n left over. That ends, just kind of instantly ends my get line, right? Because get line is looking for the line character, the end of line character, to stop. So that's why this happened. So you need to flush, and I don't have this yet. So you can't ignore. Okay. If we actually, we'll take a look at this here. No. Go ahead and check. Now, all right, so you see what happened here. So that \n is left in my input stream. Okay, I see in my integer, I'm left with a \n in the input line. what cin.ignore does, it ignores anything in the input, in the buffer, in the input stream, rather, for up to 1,000 characters. And it stops at the first occurrence of \n, throws everything up to \n away, up to 1,000 characters. So that's why my get line didn't have that \n pushed into the input stream. It was left over from cin. I know it's strange, it's special, but it's a behavior we have to take into consideration in C++ and with standard. Let's go back to the PowerPoint. Yes, it can discard all the characters up to X characters. In our case, we have 1,000, including, \n up to the specified character, which I did declare as \n. So ignore 1,000 characters up to the first occurrence of \n, throw them away out of the input stream. Okay. We can ignore or we can flush. Right? Yeah, again, same operations as C strings, only it's a little bit improved, and we have more operations as well. Okay. Characters in a string object can be subscripted. I say, so if I come over here and say, oh gosh, string is named line. Let's look at the 5th character in line. Okay, and we have just 2, 3, 4. Oh, that was a bad example. 5 is going to be white space. Try this again on 4. Or I can adjust my input string. Okay, there we go. So I got 14. What is ASCII code 14? I don't know these by heart. Anybody that does have kind of is still pocket protector. That's actually a special character. Just one moment here. See, just a second. Sorry. Yeah, I just went ahead and what I did is I got rid of my, my input there, and so I simplified. So I just deleted those 2 lines, and so I'm reading into line. This, and I'll just output the 5th file. Index 5, which should be 6th character. So 1, 2, 3, 4, 5, 6. I would expect I 1, 2, 3, 5, 6. And I got I. Okay. So you can subscript them, just like C string. Okay, and strings have a length member function. We'll return the number of characters. Okay. It's called line. Three, 4, 5, 6. There should be about 12. Yep, there we go. Length equals 12. Yep, at. You can also use at instead. So you can either subscript it or you can use at. And we'll see line 5. and we'll create an end line, say length dot at 5. Oh, and for to end confusion, we should see two i's, right? We should see I, and then we should see the length of the input, which, sorry, just a minute. Oh, fine. I need to put the name of the string there. So string name dot, and you'll have the, the at function after the dot operator. Yes. There you go. At does the same thing as the subscript. Okay, comparison does work with strings. Okay. We'll go back to our old example. We'll say S and S1 equal. It's a little different, but no matter. So this all right, so you see what I'm doing here? Just comparing S and S1 and S and S2. This should be true, and this should be not true. So I should get S equals S1, then I should see S not equal S2. Let's make sure. Yep. Okay. Palindrome. Really, a palindrome is a string that's the same backwards and forward. You see some examples here: madam, madam, a man, a plan, a canal, and a mod. Those are the two most popular. This is new to me, and so is race car. Makes sense. So it's the same from front to back. That's all. So there's an example of how to reverse, palindromes. Basically, what you're going to want to do is strip out any punctuation, any white space. Go ahead and convert, maybe to case or case, if you will, and then go ahead and reverse the string. You can read one string into another, character by character, and do it from front to back and vice versa. Right? So substring. Substring will find the location of a string within a string. It's a little auxiliary function here. And I believe that there is a question. I believe that there's an exercise on it, so I'm going to put that to you. Yeah, in fact, there's a display as well, all of 8.8. So I'm going to leave this to you. You check it out. Have any problems, any questions, just ask, of course. So conversion of C string to string, you can simply initialize a string as a C string. Okay. The other way around doesn't work. You can't push strings into C strings, and you can't copy a string into a C string, even though you use the C string strcpy still. Okay. You do, however, you do have the nice little .c_str. What that will do is convert a string into a C string. See, same thing. Basically, we're we're outputting a string here, and then we're outputting a C string here, since it converts S into a C string. That's all. .c_str as a function converts a string into a C string. And you see the example they have here. So this will work with string copy because this converts our string argument into a C string argument. So now what we're doing is copying this C string to this C string. So string copy. Remember, you can't directly assign to a C string. So this will give you a problem even though your operators, or rather your operands, are the same. You show how a string object can be used like a C string. Yeah, we convert to C string via the built-in function C_str. Read an entire line into a string object. Yes, we can do that. Remember, we have our string getLine function. Use the string function to access individual characters in a string object. Yeah, .at and then the index. You can also optionally use the subscript. Write code, convert a string to C string. Of course, you can do this. .c_str. Last but not least, vectors. So, we learned about arrays, more about arrays last chapter. Vectors are a little more useful than arrays. They don't quite replace arrays. Arrays still have their place here. However, vectors are a little more type safe. They're type safe now. They're a little safer data structures. They provide us more facilities to not shoot ourselves in the foot, kind of like strings versus C strings. And we'll see what we're talking about here. Go ahead and dive right in. Vectors, now, again, they're a lot like arrays. However, they can change size as your program runs. Arrays are a fixed size. Vectors will resize themselves. You don't even have to explicitly code the resize. You don't have to tell a vector size. Okay. Now, vectors are a little bit different. They are templated. So you see kind of the generic, have a generic here, in that you see integer. You have to declare the type of vector inside the templated little brackets there. So all this does is declare a new vector of integers named b. Okay, and you can use any base type, be it int, float, string, etc. You can even have it a vector of characters. Now, to access vector elements, you can subscript them. Okay, like arrays, they start at 0. Yes, and here's a good point. You cannot directly initialize a vector element using the subscript. You have a push_back function that does this for you. Rather initialize or update the next element of an array, or of a vector rather. Yes, here it is. Push back. So here we declared a vector of doubles, of double floating values named sample. And I want to start adding elements to it. So if I go ahead and execute this line, if I say pushback 0.0, now the first element of my vector is 0.0. If I execute this, sample.pushback 1.1, then my second element, the second element of my vector is 1.1. So now we've got 0.0 and 1, 0.0 and 1.1 are the elements of my vector. And if I execute this third statement here, sample.pushback 2.2, now my vector consists of 3 elements, 0.0, 1.1, and 2.2. Okay. Now this vector, of course, is going to be of size 3 because it has 3 elements in it. So if I say, let's go ahead and do this. And I'll just use integers instead of doubles or floats or whatever. It doesn't matter. Concept is the same. Now this is where the size comes in handy. All right, so you see I'm pushing 0, 1, and 2. So after these three statements are executed, my vector v should consist of the elements 0, 1, 2. Now, starting at 0, going up to 2, right? Because vector I is less than vector size. Just like arrays, we want to make sure that our size remains at size minus 1 so that we don't overrun the bounds of our vector. I'll go ahead and print out the element in that location. So really this should execute 0, 1, 2 is what I would expect to see down here in the output. So let's go ahead and compile, make sure it compiles. So what happened here? Vector, bound include vector. So we have to include our vector. Yep, 0, 1, 2. That's where size comes in handy. Okay, unsigned int. So an unsigned integer is an integer without a sign bit. Sign bit takes up 1 bit. In my compiler, integers are 4 bytes, so that's 32 bits. So in a signed integer, that really means at 31 bits, really we could only make use of 30 bits for a signed integer. If there's one integer, it's signed. And that's why you saw, my sign flipping back and forth, the minus and positive when I was overrunning, when I was overflowing the integer. So really on an unsigned integer, we could, on my system, we could only have up to 2 to the 31st, so we can only have 2,147,483,647, not 8, be the maximum size of my integer, an unsigned integer, or rather a signed integer. Unsigned, since it doesn't carry a sign, can make use of the whole 32 bits since it doesn't have a sign, it doesn't have a bit reserved for the sign. So now you see we're talking about 4 billion and change. So just a little bit of trivia there. Unsigned, yeah, of course they're non-negative. They can't be negative. They don't have a sign bit. My compiler didn't grab about this. Some compilers will implicitly convert. If your compiler does gripe, go back to the slide and say, oh, yeah, shoot, it has to be unsigned. And the reason is size, vector size as it's defined. If we were to go into the library and look at the code, it's available, it's open source, you can view it. We'll see that it returns an unsigned integer, but my compiler implicitly casts it, converts it. So you can also declare size. Now you don't need to. Remember, the system will size vectors and it will resize vectors. Resize vectors by itself without any intervention from you. Okay, but this would initialize the first 10 elements to, whatever the null of that type is. In case of integer, it's going to be 0. So then in that case, vector size would return 10. Okay. Yeah, like I said, it will initialize to nulls. So that's going to be kind of the default, is what I mean when I say that. So number types, it'll initialize them to 0. If it's integer, it's 0. If it's long, it's 0. If it's double, it'll initialize to 0. Booleans are initialized to false. You can go ahead and look through the documentation to see the different default values. And if you have an object, it will initialize according to the default constructor. If you don't know what that is, don't worry yet. It hasn't been covered yet. It's more object-oriented programming. So yeah, as we saw, I had to include vector. If you don't, you'll kind of be scratching your head there, and then you'll realize that you have to use the include directive for vector. Okay, and you do have to include namespace standard. Just like arrays, if you go out of bounds, you may not get an error. You'll probably get some weird behavior. So make sure you aren't overrunning your bounds, okay, or at least try as hard as possible to avoid that. It'll happen on occasion, and you'll scratch your head for a while, and then you'll find out. It's not like Java. It will not give you an array index out of bounds exception. That would be easy. So you can assign one vector to another. it will perform a deep copy. In other words, it will, will go into each element of each vector and copy it, perform a deep copy from one vector to the other, including classes. It will copy the primitives of classes. Okay, so I'll say what v1 equals v, and then I'll copy this and change everything to v1. v1 dot size vi. See. Oh, I didn't define didn't define a v1 vector. That is a problem. Zero 1 2 0 1 2. Yep. So my v1 is a direct copy of v. So capacity is how much is allocated, how much size is allocated for the vector. So for fun, let's go see how much we've allocated in memory is reserved for vector v. Four. Okay, so it's a size 3, however, it's capacity 4. Now watch this. V dot push back 1 dot push back 2. Right, so then we'll be at size 5 and we'll be bigger than our capacity. Is there going to be a problem? Let's see. So if there's a problem, we could get an error here. There won't be a problem. But if there were, we could get an error there. That's what one might expect if one didn't know better. Then we'll look at the capacity again. So go. Hey, it doubled its size. When you max out the capacity and then go beyond, vectors will resize themselves. Usually they double. Kind of can depend on the compiler, but they will double themselves. You can fine tune that if you want, but a lot of the times it's better to leave it kind of the defaults there. So yeah, I just see a common scheme is to double the size of a vector. When it runs out of space, it automatically increases. And the reason is it's going to be more efficient than allocating smaller chunks. You don't have to perform as many operations and just copy memory once and be done with it instead of copying again and again and again. Again, if you increase the size by let's say 5 at a time. Okay. And yes, you can reserve. You can explicitly declare the capacity of a vector. If you don't want that memory copy overhead, you can declare it ahead of time. Okay. So you can use the reserve function with the number of elements you want as a as a parameter to that function. And resize, you can shrink it. If it's really large, they generally they won't shrink themselves. So if you start deleting elements from it, you can call resize, so you can more efficiently use memory. Be aware that you will lose elements if there are any past this subscript here. Or that subscript -1, I suppose. Declare and initialize a vector of 10 doubles. Yeah, of course you can. Vector, open bracket, or open angle bracket, double, close angle bracket, v, and then in parentheses 10. Increase the size of a vector in at least 2 different ways. Yeah, I can think of 2 ways you could do it. You could start pushing back elements, right, and then it'll resize itself. You can also copy a vector to another vector that'll automatically resize it, right, because it performs a copy by copy, or element by element copy, rather, into the vector. So there are 2 ways you can increase the size of a vector. Difference between size and capacity. Size is the number of elements actually in the vector. Capacity is the number of elements reserved in that vector. That's all this chapter. I've been going on for an hour and a half here, so I'll stop here. We should have a fairly good grasp on this now to go ahead and proceed with the chapter and exercises. If you have any questions, just ask. See you next lecture.